Hello, pre-calculus student. This video is for chapter 3.7, part 2, rational function. We are going to look at how we can identify important features from a formula. So we have looked at 1 over x squared in the last video. Let's just pretend that we have a rational function. It's really simple. X minus 1, x minus 2. Okay, this is a polynomial. This is another polynomial. What can we say? What can we know about, where's the breakpoints, where's the vertical asymptote, etc. So, of course, anytime you write out a formula, you can identify x and y intercepts. So first, y-intercept is when x is 0. So basically, you will plug in x equal to 0, set x equal to 0, and solve for y. So in this particular case, in our case, would be y equal to 0 minus 2, 0 minus 1, and then 0 minus 2. So it will be equal to 1/2. So we have a y-intercept at 0, 1/2. X-intercepts are when the numerator is 0 because it is just when y equal to 0. So y equal to 0 just means the numerator is equal to 0. You solve for x minus 1 equal to 0. So x is equal to 1. So there's one x-intercept which is 1, 0 because y is equal to 1. So that's it. X and y intercept, you can find them from a formula just like any function. Now, if it is a rational function, there could be a point of removable discontinuity. We commonly call it a hole. So there could be multiple, but where can we find it in a formula? It is the common factor of the numerator and denominator. So a lot of time there is none, like the one that we just work on. X minus 1, x minus 2, we have two different linear factor. They're not the same. So there will be no removable discontinuity. But if there is one, just like here, x minus 2 in the numerator, x minus 2, x plus 3 in the denominator, then we would have x minus 2 being the common factor of both of them. So this removable discontinuity will happen at x equal to 2. So you solve this common factor equal to 0. So you will say solve x minus 2 equal to 0. So x equal to 2 is when the whole occur, when they are common factor. What about if I look at the formula, can I identify the vertical asymptote? If I look at the graph, it's very easy to see there is a break, right? Usually identified by dotted line. But if I look at a function like the one that we have, where is the vertical asymptote? So the vertical asymptote is a factor of the denominator. Okay, so remember, x-intercept is the 0 of the numerator. Removable discontinuity is the common factor of both numerator and denominator. And then vertical asymptote is just the denominators excluding all the common factor. Oh yeah, also, when we do x-intercept, we also exclude the common factor. Okay, the common factor cannot be an x-intercept, cannot be a vertical asymptote. It would just be a removable discontinuity hole. So you would solve d of x equal to 0. So for example, if I have a function like this here, what is the vertical asymptote? The vertical asymptote would be ignoring x minus 2 because it's a common factor. I will solve for x plus 3 equal to 0. So x equal to negative 3 is the vertical asymptote, ... Like, so if I graph it, I would have a ... line here. So say x equal to negative 3. It will break up the graph in 2 parts. So, and then what about horizontal asymptote and behavior, right? When we talk about horizontal asymptote, it's always about what happened when x is become really large or very small. So to discuss this, we would have to compare how the numerator will behave when x is really big and the denominator will behave when x is really big. Which one is growing faster? So it happens that it's controlled by the degree. So if they have the numerator's degree is lower, then the denominator will grow faster. So when you have a number that's really big in the denominator, the f of x value will become 0. So y will be approaching 0. and that is the horizontal asymptote. So this is case number 1. Case number 2 is what happened. A lot of cases, the one that you have been working on, would be the numerator's degree and the denominator's degree is the same. If they're the same, then they are going to infinity in the same rate, except by a difference by the leading coefficient. So the horizontal asymptote would be y equal to the leading coefficient of the top over the leading coefficient of the numerator, of the denominator. It's a ratio of the leading coefficient. Okay, so this is case number 2. What about if the denominator has a higher degree? There will be no horizontal asymptote. And as a matter of fact, if the numerator's degree is higher than the denominator degree by just 1, then there is a slant asymptote. Okay, so let's do some example to figure out how to do this. In all cases, in these 3 cases, we want to find out what happened when what happened, what is the vertical asymptote, what is the horizontal asymptote, and what is the removable discontinuity. Of course, you can also find x and y intercept, but we'll do that later when we need to sketch the graph. So first of all, we will look at vertical first. Well, actually, we will look at the we'll try to look at the common factor between them. Are there any common factor between them? There's no common factor, so there is no removable discontinuity. There's no hole per se. Okay, no removable discontinuity because there's no common factor. And then we are going to find vertical first. Vertical is the denominator, because this would be when the graph breaks up. It is undefined. A point is undefined there. So we'll solve x minus 5 equal to 0. So the vertical line is x equal to 5. It's VA. Then we will solve for horizontal asymptote. So for horizontal asymptote, we have to look at degree, right? So degree of the numerators is degree 1. Degree of the denominator is also degree 1. They're equal. If they're equal, what should we say? The horizontal asymptote is they go to infinity in the same rate. So who is faster will be determined by the leading coefficient. So y would equal to my writing pad is not working very well. So I would say the horizontal asymptote would be y equal to the leading term of the first leading coefficient 2 and the leading coefficient of the denominator 1. So that is y equal to 2. So graphically, we would say we expect something dotted here breaks up at 5. We expect the graph had a horizontal asymptote at y equal to 2 like that. The second one is the graph where we have 2x squared minus x minus 3. So in order to determine if there's any removable discontinuity, we need to factor them, right? So I would factor this by grouping. So let's try grouping. AC diamond first. 2 times negative 3 is negative 6. And then a negative 1 for B. So two number, negative 3 and 2, will split this into 4 parts, right? 2x squared minus 3x plus 2x minus 3 over, I can factor the bottom, x minus 3, x plus 3 because it's difference of 2 squared. And then I factor 2 by 2, right? So this would be 2, oh no, x, 2x minus 3 minus 1, oh plus 1, 2x minus 3 all over x minus 3, x plus 3. Factor further, that means is 2x minus 3 x plus 1 over x minus 3, x plus 3. So there's a lot of factoring to do. After we factor, we look at, are there any common factor? No removable discontinuity, right? Because there's no common factor. Removable discontinuity. No hole in the graph. What about a vertical asymptote? Vertical asymptote are those in the bottom that doesn't have a common factor. There's no common factor. So we would say x minus 3 equal to 0, x plus 3 equal to 0. That's two vertical asymptote, x equal to 3 and x equal to negative 3. Okay. And then what about horizontal asymptote? We would look at the degree. So the first is degree 2, the top is degree 2, and is equal to the bottom degree 2. Again, we compare the leading coefficient. So again, it is 2, leading coefficient 1. So y equal to 2 over 1 is equal to 2. So again, we have horizontal asymptote, y equal to 2. When x approaches infinity, it becomes that. Now, the third one is x minus 1, x cubed minus 8. So let's factor it because we want to discover if there's any common factor. So the top is x minus 1, but for x cubed minus 8, we know that this is difference of 2 cubed because this is 2 cubed, right? So I can factor as x minus 2, x squared plus 2x plus 4. So x cubed minus 2 cubed. So that's how you factor it. Now, no common removable discontinuity because there's no common factor, right? Removable discontinuity. Just simplify, just do an abbreviation. What about vertical asymptote? Look at the denominator. So there is one linear factor, x minus 2 equal to 0. So there is x equal to 2. Now you might wonder if this is factorable or not. X squared plus 2x plus 4 is not factorable. And as a matter of fact, has no real solution. So this would not have any zeros. So our only vertical asymptote is x equal to 2. Although there's other factor, but this is not factorable. No real solution is a complex root. So that is the only one that we have the other factor. What about horizontal asymptote? So we have degree 1, right? It is less than degree 3. So the only things that we have would be what? If we have the degree less than that, we would say the horizontal asymptote is y equal to 0. You don't have to do anything. The bottom is going faster to infinity, so it becomes 0. The next things we want to do is slant asymptote. So this happened when the the denominator's degree is higher than this one. So we say degree 2 is higher than degree 1. So we have slant asymptote. And how do I find it? You find it by doing long division. Okay, x squared minus 3, x plus 1. So divide first term by first term is x squared plus x minus will be, okay, so this is 0x minus 3. So it'll be negative x minus 3, right? And then we do, and 0x, this should be 0x minus 3. And then we do minus 1, so it'll be oopsie. Okay, I want to see. If I do minus 1, it will be negative x minus 1. So subtract, that would be 2. So our slant asymptote is y equal to x minus 1. So what is the next one? The next one is doing sketching. So we will use the next video to do it. Okay, so that's how you find horizontal, vertical, and removable, as well as slant asymptote.